First of all, let's get back to our school days and try to understand what matrix multiplication is and how it works. As here we can see, this is one matrix, I can call it A, and this is second matrix, I can call it B, and we are multiplying these two to produce another matrix which is C. Now the way this calculation is done is, we say, like, what we'll do is we'll multiply 1 with 7 here, and then 2 with 9 and 3 with 11. So we multiply these three things, and whatever sum comes of that multiplication, so we can say 1 into 7 plus 2 into 9 plus 3 into 11. So this sum will be 7 plus 18 plus 33. Now if we add them, 33 plus 7 is 40, 40 plus 18 is 58. So we get the first term of the final matrix, right? So this is how we get the first term. Now in order to get the second term, here what we do is we start with the first row again, and here we start with the second column, and then we multiply the same way. 1 into 8 plus 2 into 10 plus 3 into 12. So 1 into 8 will be 8, 2 into 10 will be 20, and 3 into 12 will be 36. So if we add 36 plus 8 is 44, plus 20 is 64. So with this we got the first row's answer. Same way, now when we get to get the second row's answers, we'll take 4, 5, 6 and multiply with first column, then we'll take 4, 5, 6 and multiply with this column, and that's how we produce the resultant matrix. Now the thing that we have to think about, like, what is it that we are going to get into, we have to understand answers to few questions. The first question that we need answer to is that if we want to multiply two matrices, then their dimensions, like here if you see, this has 2 rows and 3 columns, and the second matrix has 3 rows and 2 columns. Now in order to even multiply two matrices, they should have, their first matrix should have equal number of columns as second matrix has the rows. Only then this is possible. So this is the first learning. So we can multiply a 5 cross 3 matrix with a 3 cross 2 matrix also. This is possible and this is doable. So only criteria is the number of columns in the first matrix should be equal to number of rows in the second matrix. So that's the first thing to understand. Only then matrix multiplication is possible. Now second is, how many elements will be present in the final matrix, which is C. So resultant matrix will have how many elements? That will depend on the number of rows in the first matrix and number of columns in the second matrix. So if you multiply 5 by 3 matrix and 3 by 2 matrix, ultimately we are going to get a 5 by 2 matrix as an answer. So that comes from these. So here if you see, final matrix was 2 by 2 because that's the answer, right? And the last thing that we need to understand is how many scalar multiplications are required to get to the resultant matrix. When I say scalar multiplication, what it means is, here we see that 1 was multiplied by 7. So this is one multiplication, 2 is multiplied with 9, this is second multiplication, 3 is multiplied with 11. So in order to get this element, we performed total 3 multiplication, 1 into 7, 2 into 9 and 3 into 11. Same way, when we come to the next element here, how many multiplications are required to get this? Here also if you see, 3 multiplications will be required because 1 into 8, 2 into 10 and 3 into 12. So here also 3 multiplications are required. Now how we are getting to know how many multiplications are required is, the first matrix was R cross C and second matrix was C cross T. Then we are saying for every element to be produced here, we need C multiplications to be done, right? So this is C, this is C, this is C, this is C. So total, how many times these CC calculations are required is, that is equal to the number of elements in the final matrix. And final matrix we discuss, it's R into T is the dimension of final matrix. So can we say that in order to get the final matrix, R into T elements have to be obtained, and for every element we need to do the C calculation. So overall, if we are multiplying two matrices of size R cross C and C cross T, that means each element of the first matrix getting multiplied by each element of second matrix, how many those scalar multiplications are required is R cross T cross C. So this is something to keep in mind. Now let's summarize whatever we have discussed. We are saying if we are multiplying two matrices of size A cross B, Then what is the dimension of final matrix? Just try to internalize whatever we discussed. Try to answer this question on your own. If input matrices are A cross B and B cross C, then what is the dimension of final matrix? Second is, what is the total number of elements that are present in the final matrix that we are getting based on the dimensions of given input matrices, these. And last question to answer is, what are the total number of scalar multiplications required to be done for any given matrix? So if you are able to answer these three questions, then we are good to proceed with our next topic.